Hi there. 8.2 picks up right where 8.1 left off. The difference here is that we're talking about systems of linear equations in two variables. And notice it asks us to use the elimination and addition method to solve. Now, I want to point out something that perhaps you've taken for granted up to this point when you've talked about the elimination or the addition method, and that would be these three facts up here. These are going to come in big in a couple lessons when we get to talking about matrices. And so let's look at a couple things here that we can do. When we get ready to solve this system, it really wouldn't matter if we wrote negative 2x plus y equal negative 28, then 3x minus 2y equal 11, or we could put 3x minus 2y equal 11 on top, and we could put negative 2x plus y equal negative 28 on bottom. Really wouldn't matter which direction we go there. We'd get the same thing. Alright, you'll notice that we can multiply or divide an equation by a non-zero constant. And you're also going to notice that we're going to take a constant multiple of one equation and add it to another. For instance, if I take 2 and multiply that top equation by 2, and I think probably you'll recognize why I want to do that. Okay, there's my top equation, bottom equation. I'm going to leave it alone. 3x minus 2y equal 11. Now what I'm doing, I'm going to multiply here negative 4x plus 2y equals negative 56. And then here I've got 3x minus 2y equal 11. So this is now a multiple of the top original equation. Now I'm going to take it and add it to the other. Look, I get negative x, the y's drop out. This equals negative 45. And so x equals 45. And then we know, once we know the value for x, we can plug it back into one of our originals here. If I take it, plug it in right there, negative 2 times 45 plus y equals negative 28. Well, let's see what we've got here. Negative 90 plus y equals negative 28. If I add 90 to both sides, alright, y equals 62. And of course you need to check these, but 45, 62 will give you the solution to the system. Now, something that you maybe didn't do a lot of back in your last math class when you were solving systems using substitution or the addition method, and that's what we want to use here, the elimination and addition method. Guys, we've got equations here that involve fractions. I'm going to clear those fractions first of all, okay? 1/2 t minus 1/5 v equal 3/2, man. Let's get rid of those. Let's multiply everywhere by 10. So 5t minus 2v equal 10 divided by 2 is 5 times 3, that's 15. And then second equation here, 2/3 t plus 1/4 v equal 5/12. We're going to multiply everywhere by 12. 12 divided by 3 is 4. 4 times 2t is 8t. 12 divided by 4 is 3. Plus 3v, and the 12's drop out. This gives me 5. And we know that we need additive inverses in front of one of the two variables. I'm going to multiply this top equation now by 3, the bottom equation by 2. What I'm going to get is 15t minus 6v equal 45, and 16t plus 6v equal 10. So we get 31t equal to 50 equal to 55. And so when we divide both sides by 31, we see that t equals 55 over 31. You're thinking, well, my goodness, that's messy. Yeah, well, what do you expect when you've got a system that's got a half, a fifth, 3/2, 2/3, 1/4, and 5/12 is the numbers you're working with? Probably not going to be real pretty. And then we've still got to find v. So what I'm going to do, I'm going to take the equation 5t minus 2v equal 15. I'm going to take this 55 over 31 and plug it in for t. So 5 over 1 times 55 over 31 minus 2v equals 15. Okay, well, let's see here. 275 over 31 minus 2v equals 15. And then negative 2v equals 15 over 1 minus 275 over 31. Alright, so negative 2v equals, let's see what we get here, 190 over 31. A little calculator help. And then I'm going to divide both sides by that negative 2. Okay, I'm going to divide both sides by negative 2 here, and so we find out that v equals negative 95 over 31. And when you get ready to write this as an ordered pair, you alphabetize, of course. So 55 over 31, comma, negative 95 over 31. Whew, that was a little messy, but hey, we know what we need to do, okay? We know how the addition method works. We just need to put it in play and go with it. Certainly, if you have questions about that, bring them to class. As always, we'll be happy to take a look at them. We ought to be breathing a little easier here because when we look at this system, x minus 5y equal 2, that's always good. Elimination method, you got a 1 in front of one of the variables. Good news indeed. 3x minus 15y equals 6. Guys, this is just screaming for me to multiply that top equation by negative 3. Negative 3x plus 15y equals negative 6. 3x minus 15y equals 6. Add down, we get 0, 0, 0. Well, that's interesting. That's interesting. What are we going to do about that? Well, we know that when we get 0 equals 0 on a linear equation, we know that we've got an identity with an infinite number of solutions. And so you can write that there are an infinite number of solutions, but you know what? Doesn't that seem just so beginning algebra-ish? Don't you feel like, hey, I'm in college algebra now, Kev, can't I do better than that? The answer is, you betcha. You betcha. We can actually describe what some of these solutions are going to look like. You see, if I take x minus 5y equal 2, x is really equal to 5y plus 2. And so ordered pair here, 5y plus 2, y. And for any y I pick, you know, if y, let's say, were 0, then x would equal 5 times 0 plus 2, which would be 2. So for all of you that are heading into a linear algebra course, you would find out that this is the general solution and that the ordered pair 2, 0 represents a particular solution. Right now, all I really care about is that you know this is an infinite number of solutions and that you can write this general solution. Alright, and you know what, while we're at it, go ahead, I'm going to lie to you here, I'm going to go ahead and ask you to be able to find a particular solution as well. Alright, so if you have questions about that, please bring them on. Let's take a look here at this next example. Once again, there's reason for excitement. Why? Because, well, there's a 1q by itself, or a negative 1q. What do we have here? Negative 12p plus 4q equal 3. Now, guys, if I multiply this top equation here by 4, we get 12p minus 4q equal 28. Bottom equation, negative 12p plus 4q equal 3. Let's add down. The p's are gone, the q's are gone. But on the other side, we've got 31. Guys, we can't do anything with that. That is a contradiction back in the old days, and just like it did then, it leads us to no solution now either. Alrighty, let's take a look at a situation that maybe you haven't seen before. looking at this equation, or this system rather, we've got 6 over x plus 10 over y equal negative 1, and 4 over x minus 5 over y equal negative 3. Now think about this, guys. I'm going to take a minute here and I'm going to let a equal 1 over x, and I'm going to let b equal 1 over y. And if I do that, watch this. This becomes 6a plus 10b equal negative 1. And this becomes 4a minus 5b equal negative 3. Okay, man, doesn't that look a lot nicer to work with than this mess? Because now, folks, I recognize I can multiply this equation by a constant, so the top equation stays the same. The bottom equation multiplied there by 2. 14a equals negative 7. A equals negative 1/2. Well, keep in mind, though, folks, what we said a was equal to. We said a was equal to 1 over x. Alright, and so 1 over x equals negative 1/2. If you think of it like this, 1 over x equals 1 over negative 2, then it becomes very easy to see that x equals negative 2. Okay, x equals negative 2. Now guys, knowing now what x is, we've got some options here. We have said that we've got basically 6 over 1 times 1 over x plus 10b, and this equals negative 1. Alright, but this becomes 6 times 1 over negative 2 plus 10b, this equals negative 1, negative 3, plus 10b equal negative 1, 10b equals, we add 3 to both sides, this gives me 2, b equals 1 over 5, and we know that b is equal to 1 over y, so we see that y has to equal 5, and so our solution here is negative 2, 5. I'm going to do the same thing in the next example, guys. That was so much fun. Let's do it again. We've got 3 divided by x minus 1 plus 4 divided by y plus 2 equal 2, and 6 divided by x minus 1 minus 7 divided by y plus 2. So we're going to let a equal 1 over 1 minus x, or I'm sorry, x minus 1. I'm going to let b equal 1 over y plus 2. And so we've got 3a plus 4b, and this equals 2, and I've got 6a minus 7b, this equals negative 3. And we can see here if we multiply this top equation by negative 2, so I've got negative 6a minus 8b equal negative 4. I've got 6a minus 7b, this equals negative 3. Okay, we're going to add down, the a's disappear, negative 15b equals negative 7. So b equals 7 over 15. I mean, you weren't really expecting something pretty a second time, were you? And so now with that knowledge, we can solve. We know what b is. 7 over 15 equals 1 over y plus 2, so we get 7y plus 14 equal 15, 7y equals 1, and y equals 1 over 7. Okay, and then we can plug that right back in. What I did, I took 6 over x minus 1 minus 7 over 1/7 plus 2, and I found this to be equal to negative 3, we know. So 6 over x minus 1 minus 7 over 1/7 plus 2, this is 15/7. This equals negative 3. Alright, so 6 over x minus 1 minus 49 over 15 equals negative 3. And we can add 49 over 15 to both sides, so 6 over x minus 1 equals negative 3 over 1 plus 49 over 15. And so this gives me 6 over x minus 1 equals a little fancy fraction work here, 4 over 15. Multiply by 5, multiply by 5 there, and then reduce. And so we get 4/15. Little cross multiplication, 90 equals 4x minus 4. 94 equals 4x, so x equals 94 over 4, which is 47 over 2. And so my solution here is 47 halves, comma, 7/15. Pretty exciting stuff, huh? Some nice fractions and even fractions in our answers. Didn't give you any problems for class discussion, but certainly a couple odds there. Have questions on them, bring them up. Let's go back to the days when we were in kindergarten, the good old Crayola crayons. I don't know. I was probably in kindergarten a few years before you guys were. Maybe you didn't have the Crayola crayons, but this is what this reminds me of. It says a crayon 8 centimeters in length and 1 centimeter in diameter will be made from 5 cubic centimeters of colored wax. Now let's think about that for just a moment, shall we? 5 centimeters of colored wax. We know that the volume of this part of the crayon is equal to pi. Alright, let's write a volume function here. Pi times the radius squared times the height, and then the volume of the cone on the end is equal to 1/3 pi r squared times the height. So let's just get our volume down here real quick. We know that the volume is equal to 5, and this is pi times, now my radius of this particular the radius of this particular crayon, well, if it's 1 centimeter in diameter, that means its radius is a half. The height we know to just be x, okay? That's x. And then over here we've got 1/3 pi. Once again, our radius is a half. We're going to square that. And the height of this guy, of the cone here on the end, is y. Now the other thing to note is that if you take y, add that to x, x plus y equals 8. So we've got two equations here and only one unknown. This is good news. This is good news indeed. And what I'm going to do is I'm going to take this top equation, or this right equation I should say, y equals 8 minus x. And so let's see what we've got here. 5 equals 1/4 pi x plus, this is 1/4 times 1/3 is 1/12 pi times 8 minus x. Alright, let me simplify this. We get pi over 4 x plus 2/3 pi minus pi x over 12. And we know that that's going to equal 5. Now, it's kind of nice here because if you check this out, we could here actually go ahead and clear the fractions. I'm not going to, but let's do this. Let's get all of our terms with a variable in them on one side by themselves. So 5 minus 2/3 pi equals pi over 4 times x minus pi over 12 times x. Alright, so 5 minus 2/3 pi equals x times pi over 4 minus pi over 12. So x equals 5 minus 2/3 pi divided by pi over 4 minus pi over 12. Okay? And, we should probably go ahead and clean this up just a bit. If we'd hit all of these, multiply all of these top and bottom with the 12, we'd at least get rid of our fractions. We never want to leave fractions over fractions in a final answer. That's just not good. So we get 60 minus 12 divided by 3 is 4, times 2 is 8 pi, 12 divided by 4 is 3 pi, and minus pi. So 60 minus 8 pi divided by 2 pi, we can take a 2 out. 30 minus 4 pi all over pi. This equals x. Remember what x is? It is the length of our crayon. Find the length x of the cylinder. So there's the length of the cylinder. And now let's look for y. I'll come over here. Y equals 30 over pi minus 4 over 1. And, well, that was x. I needed to subtract that. My apologies here, getting all excited. So we've got 8 minus 30 over pi, and then minus a negative gives me a positive, so we're looking at 12 minus 30 over pi, and these are in centimeters. This is the height of the cone. That too is in centimeters. So that crayon problem maybe not quite as ugly as you would have first thought. Finally, for this lesson, we've got a large table for a conference room. It's constructed in the shape of a rectangle with two semicircles at the ends. The table is to have a perimeter of 40 feet, and the area of the rectangular portion is to be twice the sum of the areas of the two ends. So find the length L and the width W of the rectangular portion. Now let's think about this for just a second here, folks. We can break this down into the rectangular part of the table, and guys, if we put those two ends together, we get a circle. Alright, we know this is L. Notice that the width of the table, okay, is W, but that also happens to be the diameter of my circle. So we know some things. We know the area of this circle is pi times its radius, which is W over 2 squared. We know that the circumference of this circle is pi times the diameter, or if we, I guess we can go pi times the diameter. Alright, that would be good. And over here we've got the area of the rectangular portion, which is length times width, and we've got the perimeter, which is 2L plus 2W. Now let's see what we know. We know that the table is to have a perimeter of 40 feet. Now guys, that's the area all the way around it. And so the area all the way around it is basically going to be here, here, and then your distance around the circle is really what your perimeter is going to be. So the perimeter of the table is going to be 2L plus pi W. Alright, and of course you say, well, that's great and all, Kev, but you've got a perimeter function now in two variables. Well, yes I do, but we can do something about that. The table has a perimeter of 40 feet. Okay, so we know that 2L plus pi W is going to be 40. Alright, so 2L plus pi W is going to be 40. And if we solve that for L, 40 minus pi W divided by 2, there's L. And so now with that in mind, what we want is for the area of the rectangular portion to be twice the area of the two ends. Alright, so this equals L. Alright, and so the area of the area of the rectangular portion is going to be A of W equals W times 40 minus pi W over 2. Alright, and we distribute this, we're going to get 20W minus pi W squared over 2. And we want that area to be equal to twice what the area of the two ends are. Well, a minute ago we said here's the area of the two ends. We want this now. We want this area to be twice that, so we want 20W minus pi W squared over 2. We want that to be 2 times pi times W squared over 4. Now let's clean this up a bit. 20W minus pi W squared over 2 equals, these guys cancel. We've got W squared pi over 2. Okay, and if we clear the fractions here, guys, let's go ahead and do that. 40W minus pi W squared equals pi W squared. So 40W minus 2 pi W squared equals 0. And if we take out a 2W, we're left with 20 minus pi W. This equals 0. Of course, W can't equal 0. We're not going to have anything. So 20 minus pi W equals 0. And this means W has to equal 20 over pi. That's my width. Okay. And then a little while ago we said, hey, if we know our width, we can find our length. So 40 minus pi times 20 over pi divided by 2. Pi's drop. 40 minus 20 is 20. Divided by 2 is 10. And there's my length. So there are the dimensions of this particular table. Our dimensions here are in feet, so 10 feet and 20 over pi feet. I've given us a little more room to work here than I originally had for this last problem in this section. It says a 300-gallon water storage tank is filled by a single inlet pipe, and 2 identical outlet pipes can be used to supply water to the surrounding fields. It takes 5 hours to fill an empty tank with both outlet pipes open. If we close one outlet pipe, it only takes 3 hours to fill the tank. Find the flow rates in gallons per hour in and out. Well, what I'm going to do here is I'm going to let X, as soon as I get my pen back up and going again, I'm going to let X represent the flow rate in, and we're going to let, I didn't even write X, and then we're going to let Y represent the flow rate out. Now, what you might notice here, we've got 1 coming in, 2 going out. It takes 5 hours to get this water tank full. And if we only have 1 pipe going out, we've got 1 coming in, 1 going out, we can fill this bad boy in 3 hours now. So we've got a relatively easy to deal with system of equations here. 5x minus 10y equals 300. 3x minus 3y equal 300. And you know, if I would have been thinking a minute ago, and it's not too late, let's take a 5 out of the top equation. X minus 2y equals 60. Let's take a 3 out here. X minus y equal 100. And so if I hit this bottom equation with a -1, x minus 2y equals 60. Negative x plus y equal -100. So negative y equal -40. Y equal 40 gallons per hour. And y is the outlet. So that's how many are the rate at which they're flowing out. And then a little bit ago, we said that x minus y equal 100, so x minus 40 equals 100. X equals 140 gallons per hour flowing in. And this concludes our second lesson here in this chapter. Certainly I've given you a couple problems here to work for class discussion and for homework. If you've got questions on those, certainly bring those in. Be glad to look at them. Thanks for watching.